Hello, I'm Richa Gautam, and today we'll learn about the topic free fall from kinematics. So, the learning objectives for today's lecture are to understand the concept of free fall motion, what happens when we throw a ball, how the motion, the position, velocity, and acceleration, all these variables they change, and we'll learn about the formulas related to the free fall motion and how we can get these formulas from the kinematic equations that we have already done in the previous lectures. So these are all the kinematic equations, and we have done these equations which gives us the relation between the final velocity, initial velocity, acceleration, time, and the displacement, either along the y-axis or along the x-axis. So the free fall motion. So the basic definition for this free fall motion is any motion of a body where gravity is the only force acting upon it. So whenever the object is under the effect of only gravity during its motion, so that kind of a motion is known as a free fall motion. So suppose we take first case when we just drop a ball. So what happens in this case, if you see, so we are just dropping a ball, and at this point the initial velocity of the ball is 0 meter per second, and the man is standing at this height h above the ground. So during this whole motion, what is going on with velocity and acceleration? So the moment we are going to drop the ball, the velocity vector here will be in this direction, and it's going to keep on increasing because it is going to speed up. And the acceleration, it's also going to be in the same direction with the same magnitude, 9.8 meter per second square, which is our gravity value. So since the velocity and the acceleration, they both are in the same direction, so this ball, it's gonna speed up its motion. Now, the second case that we can take in this is when we throw the ball up. So if we are throwing the ball up, we are gonna throw this with certain velocity vi. So this velocity here, vi, now it's not zero, it has certain value, and the person is again standing at certain height. So now we'll see how the velocity and acceleration vectors will change in this case. So the velocity vector, the moment it's going to throw the ball up, the velocity magnitude will keep on decreasing, and the motion, the upward motion, will slow down. So this velocity here is this with this much magnitude, it will decrease, and at this maximum, at the peak, the velocity is going to be 0. So at this point, 0 velocity, after this, what's going to happen? The ball, it will start going down, and the velocity vector will increase in magnitude because the motion is downwards. And in this case, if we see what is going to happen with the acceleration, so acceleration is all the time is acting in the downward direction, whether the ball is at this initial position or it's at this peak, then again it's going downwards. So at each point the acceleration is acting towards the ground, which is the g, the acceleration due to gravity. So what happens during this whole motion? The free falling object, it accelerates, it changes its velocity. Initially, when you threw up the ball up, the velocity is decreasing. So when it moves upwards, it slows down because the velocity vector is opposite to the acceleration vector. But when it moves downwards, it speeds up. It speeds up during this downward motion because now the velocity vector and the acceleration, they both are in the same direction. So this is the second case, and third one is when we throw the ball down. So now we are throwing the ball down with certain velocity. So this velocity vi, now this velocity is not equals to 0, but we are giving certain value to this velocity. So this velocity, again, it's gonna go along this direction, the velocity vector, and our acceleration, it is also along the same direction, so it's gonna speed up during this motion. So if we see all these three cases, the acceleration, which is obvious that we know, like the object, they all go towards the center of the earth on the ground. And why? Because of the acceleration due to gravity, which is our g value and which is a constant 9.8 meter per second square. So let's discuss this more. So what happens during this free fall motion? So free fall motion, the objects, they always accelerates with the magnitude of 9.8 meter per second square. And this value is also known as the acceleration due to gravity that we know. So what happens during this free fall motion? The acceleration that the object is having is equals to this g value, and since it is always acting in the downward direction, so it is gonna come with the negative direction. So now what we can say about all our kinematic equations, what we are gonna do, we are just gonna replace the a with negative g in all the equations, and all our kinematic equations, they will transform to the equations for the free fall motion. So now there is one more very important point that we should discuss about this free fall motion, that the free fall motion, it does not depend on the mass, the direction of travel, or the speed of travel. We just discussed about this, the direction of travel, because in the second case the ball was going firstly upwards and then it came downwards. In the third part and the first part, the speed of travel, initially the vi was 0, in the third part the vi was not 0. So how can we explain this, that the free fall acceleration does not depend on the mass? So there is a very important this experiment, and we always approximate the assumption. We always take this assumption that this free fall motion, it happens when there is no air. The air resistance should be 0. Only then we can study this free fall motion. So suppose if you take this this animation. So in the first part, there is one block of this stone rock, and we have this paper. We are just gonna throw these two objects in the presence of air. So what's happening? The rock, it's gonna reach the ground first, but the paper, it's not only under the influence of gravity right now, it is under the influence of air resistance too. So that's why it's taking some time to come and reach on the ground. But if you see on the other hand side, if there is vacuum and there is no air resistance, there is no air present, then you can see that both the objects, the paper and this rock, they both are going to reach the ground at the same time. So this example, this is the explanation of free fall motion. Means when these objects, they are solely under the influence of gravity. There is not any external force is acting on these two objects. So now we can try this problem. So you will get these three cases that we discussed. You might get problems like based on those three cases. Let's just try how we can solve this one. So just a drop ball. So you're gonna use all your equations that we just saw about the free fall motion. So suppose you have this height of the building is 8 meters. In this case, this h is 8 meters. During this drop ball, the initial velocity of this ball is 0 meters per second. So this is given to you. So we have what all is given to us. The h is given to us, and this h is equals to 8 meters. The vi is equals to 0 meters per second. So suppose the first part asks us how long to hit the ground. How long is this ball is gonna take to hit the ground? So means what is the unknown in this part? This part, the unknown is t. So now we need to see which equation can we use out of these three equations. So in the first equation, it says final velocity is equals to vi minus gt. So if you see in your given data, you don't have a final velocity. So let's try the second equation. Second equation say that delta y is equals to vit minus half of gt square. So when you plug in the values, delta y is the displacement along the y-axis. So displacement means y of f minus y of I, the final position minus initial position. So the final position here is this 0 meter. The initial position here was 8 meters. And this is again vi and t. So since this was 0, this whole thing is gonna get 0, and negative of, so we are just gonna left with negative of gt square. So yf is our 0 meters minus of yi is the 8 meters equals to negative 9.8, which is the g value, the constant, and with the t square. So when you will calculate this whole thing, negative of half 9.8 with the t square, after calculating this whole equation, I got the t value 1.28 seconds. So this is how you can find these variables from this problem. And the second part is how fast is it moving just before hitting the ground. So this problem is for you. You need to find out how fast, means what is the unknown in this part? The VF. So you have H given to you, you have VI, and you have the T values now. Now try how fast is it moving just before hitting the ground. So this problem is the assignment for you. Just try to do, and let me know if you have any further questions for me. Thank you so much.